Good morning, everyone. Welcome to the Enerplot webinar that we're going to be hosting today. I'm glad that you all can join us from all over the world. I guess I should also say good afternoon and good evening as well. The way I'm going to be doing this is I'm going to start off with just an introduction to the software using PowerPoint, and then I'm going to jump back and forth between PowerPoint and the software itself, just to demo some of the features for you. Afterwards, if you want to ask questions during the webinar, you can through the chat window or on your GoToWebinar panel. There's a panel of experts sitting waiting to answer any of your questions as I'm talking. Afterwards, if you have any more questions that you'd like to talk to us, we'll stick around after the webinar is completed. Just keep the lines open, and you can continue to ask questions, and we'll answer those for you. All right, so I'll continue on. All right, so what is Enerplot? Well, it's just simply a software tool that's used to display and analyze simulated or measured data in an offline environment. It supports multiple different types of files. Here's a list of them here. Of course, we support PSCAD or EMTDC output files. Also the harmonic frequency scanner output inside of PSCAD, if you are a PSCAD user and familiar with those things. It also supports ComTrade, both 1991 and 1999 formats, ASCII and binary. PSSE files, both .out and .asc, are also supported. And if you are a user of the RTDS, the RSCAD GUI front end for that, its output files are also supported in Enerplot. On top of those specific ones, we also support the import of CSV files and text files as well, both formatted and unformatted. Once you load any of these files into Enerplot, all the file types can be converted to comma-separated value or ComTrade formats, or like saved as those types of files from Enerplot. So before I continue on anymore, I'm just going to make you familiar with some of the terminology that I'm going to be using. Sometimes when you're developing software, you have to name things, and you know, if you're a user of the software, you may not be familiar with that. So the first is a record, and a record just represents an array of data points that could be either a single curve or a multiple curve. If you're a PSCAD user, this would be if you can imagine putting an array of data signals into an output channel, and you get one curve entity from that. That's what I mean by that. Records become curves as soon as they're plotted in graphs. A data set is a collection of records. That's normally defined by a single or a collection of files. If you can imagine the EMTDC output files, you have an information file that associates all the output files together. So when you load that information file in, it comes in as a single data set. A sheet is a single page or canvas on which you can place graphs and other display objects. And these sheets can be collected into what's called a book. And the book itself is kind of similar to like a project file that has its own file type, its own extension. So that book will hold multiple sheets inside of it and contain all of the information about the graphs and where you place them on the canvas and stuff like that. A script is simply a Python script file, and we'll get into that in a little bit. And finally, the workspace. Workspace is a collection of books. It's stored as a single file. It's actually a collection of books and data sets and scripts, and it's stored as a single file, but it contains the links to all your books and data sets and scripts that are contained with it. So you can have your files all over your computer, and when you load up that workspace, it automatically grabs all the files that are associated with it and brings it into one general area. But as I said, the book files remain as separate, and the data sets and the scripts, they all remain as separate files, but the workspace just has links to everything together. So some major features that I'm going to talk about today. Here's a list of them here. So we'll talk about the new automation interface that we're putting into Enerplot. This, unlike the one that we have in PSCAD, this one is completely an embedded environment, and it will also eventually allow you to record actions, or so you will actually you can create new script files, generate new script files just from performing actions while you're recording. There's a record wizard that allows you to generate new records based on existing ones. And it includes a math parser. So if I want to say add records together or take the square root of a record or something like that, you can use the record wizard to do that, and it will generate a new record for you based on whatever you've defined it to be. In terms of data manipulation, you can, once a record is displayed in a graph, you can shift or translate it in both in the Y and the X directions. You can scale the record, or you can even manually adjust the record, like actual record points. So particular wide ordinate axis points, you can actually manually modify. So also there's a quick loading feature. This is something that people had asked for immediately. They had asked for immediately once we put this out, because if you have super large files, sometimes they can take seconds or possibly even minutes, depending on the size. If you're loading, if you need to load all of the data that's contained into the files into memory. So there's a quick loading feature. I'll talk about that a little bit more later on. You have the ability to clone or template both books and sheets quickly and efficiently. So, you know, if you set up a book that has a bunch of sheets in it, and you have graphs laid out all over the place and curves in those graphs, you can easily just clone the book and create a new book based on that one. Data referencing, you can easily switch between data sets that are associated to books or reference to books. You can switch between them. You can delink and relink and all that nifty stuff. So the current status of the software, we're still in beta development stage, meaning that it's available for people to have a look at if they like, as we continue on with development of it. The embedded automation environment that I mentioned previously, it's still in alpha stage of development, but hopefully it'll be ready soon so that we can get it into the beta and the beta testers can start using it for us. We are hopefully wanting to release the product, you know, in early 2019. That's the plan at this point. I know a lot of people are eager to start using the software. So what we're going to do is we're just going to, you can give us a shout on the support@pscad.com email. You can address it to me personally, and just ask if you just say you would like to participate in the beta program, and we'll set you up with a certificate license so that you can so that you can use it like a temporary certificate, so that you can use it while we're still working on it, and then we'll stop all that once it's released. So Enerplot's a pretty simple program. It consists of just a few different parts. One of them being, a bunch of basically just a bunch of windows, and one of them being a workspace pane. There's a canvas pane for placing graphs and stuff on it. A data reference pane for manipulating references and a display of references and that sort of thing, and also a data view pane so you can actually look at the data that you're viewing, and a ribbon control bar that has some main features and stuff, or controls in it that you can use. So I'll start off then talking about the workspace pane, and I'm going to just quickly switch over to the Enerplot beta here. All right, and so here it is. This is the Enerplot program. I was talking about the workspace here. This is the workspace up here in the top left corner. I'm not sure if you can see my mouse, but you can figure it out. It says workspace right on it. So in here, we have two provisions. One is for creating books, or for adding books to. You'll see that one is already here created when you start with a new workspace. That book can be saved as whatever you want to name it. I'll name it John. You can put a description in here. I don't know, whatever. I'll put whatever, and it can appear here on the side. So this is where you add the books. Each book contains a sheet, one sheet by default. The sheet is displayed on the canvas. This is the larger window, more to the right here. You can add multiple sheets to a single book by just selecting new sheet. And you'll notice that there's a second sheet here now. Of course, these can be renamed. Description can be put in. You'll also notice that at the bottom of the canvas, for every sheet that you add to this particular book, there is a tab associated with it for so you can easily navigate between the sheets. So you can add many sheets if you like to the book. So for data sets and records, these are loaded in a couple different ways. You can either load a data set from a file, or you can paste a data set from the clipboard directly. So I'll try loading a data set from a file. I go into my collection of files here, and I'll select, say, this is a EMTDC output file. You'll recognize the INFX format. I select that, and it opens up the data set. And that is going to contain a bunch of records. So this one has 24 records, which is displayed on the side. And each one of these records will be displayed as a curve as soon as you put it into a graph. Pasting data from the clipboard, I just happen to have a text file here that looks to be space or tab delimited. I'm just going to select, it contains a time and two y-axis columns, so I'm going to end up with 2 records. I'm going to copy this data and go back to the data set and paste the data directly into there. So you'll see that those 2 records that I had in there are already loaded in. Okay. Okay, so let's take a look at the types of graph panels that we have. There are 4 types. There's the overlay graph panel, which overlays curves on top of each other in a single graph. You can see that down in the bottom right corner here, that has two DC current and DC volts on top of each other. There's the polygraph, which is a graph of stacked curves, so it's only a single curve in each row. An XY plot, where you can graph 2 time domain curves against each other. So in this case here, we have an AC voltage 1 and AC voltage 2 that are act as both the X and the Y coordinate, and they're graphed on an XY plane. And there's the FFT frame as well. So you can put any signal into this frame, and it will automatically, based on the markers, it will automatically calculate an FFT, both magnitude and phase angle for you. Okay, I'm going to switch back to Enerplot again here, and I'll just show you how we can quickly and easily create curves and graphs. So I can grab any one of these records that I've already loaded into this workspace, and what I'm going to do is I'm going to select the record. I'm going to hold down the control key and then hold down the left mouse, and I'm going to drag it across onto the canvas and just create the curve right on the canvas. So you can see that Enerplot will create the panel for you, add the curve to the graph, and plot the curve as well. If I want to add, that's the load current, I can also add the midpoint voltage by just doing the same thing and plotting that on the canvas as so. I'm just going to load up a quick example here. So what I'm going to do is, this is the workspace that I started with. I'm going to go up to the top and select one of the example case that comes with Enerplot. This is the main example case here, and it's going to ask me if I want to save any changes, and I'm going to say no, and there we go. So we opened up the main Enerplot example. So this one here contains, I can show you the, if I zoom into this plot a little bit here, you'll see that we have the markers set up to do an FFT. These are just simple sine waves, so you're not going to really get much of an interesting FFT spectrum here. But it will dynamically calculate the FFT as you move your markers around. I'm starting to get a bunch of garbage now, of course, because I don't have a perfect 60 hertz waveform in here, so it's going to start giving me some garbage results. But you see what I mean by that. All right, we have I showed you the overlay graphs already, the stacked polygraphs. If you scroll down a little bit, we have an example XY curve here. You can zoom in and zoom out as well. All right. So back to the PowerPoint. Okay, so the first thing I'm going to talk about is cloning books and sheets. What you can also call it templating as well. Books and sheets can be cloned very quickly within the workspace. I'll show you how to do that. A single book or sheet can act as a template then, and so if you create just one, then you can just use that as a template to create multiple other ones really fast. So that way you don't have to put them all back together again. This is very convenient when you're displaying records from multiple data sets that are that have identical or a similar structure, say for instance a multiple run study or something like that, or if you're doing the same study over and over again, you can template the previous study so that you don't have to spend time setting up the display and that sort of thing again. So I'll switch back to Enerplot again here, and I'll show you how to clone the sheets or clone the book. So here I have the main book here, book 1. It already has, I'm connected to a bunch of data sets already. It has a bunch of curves in it. I can clone this book by simply right-clicking on it. Oh, sorry. There we are. That's better. Okay, so I can clone this book by just selecting clone, and I can clone it with all of the data links or without all the data links. So I'm going to select to clone it without all of the data. And so here it will automatically create a new book for me. It's all laid out with the curves and all of the settings for the graphs and everything ready to go. But it's not linked to any of the data. If I want to link to the data, I simply just can quickly do that, and we'll get to the data referencing in a bit. So also, this book contains only a single sheet, but sheets can be easily copied and pasted. So here I went in, I select copy sheet, go back to the book, and just simply select paste sheet. It will rename it to a different name, and then there we go. So now I've just cloned the sheet again. It has everything that's everything in it that the previous sheet had. So you can see how this could be a great time saver, being able to clone the books and the sheets so quickly. Okay, so data referencing. Each book, if you put as soon as you put a record from any of the data sets that you have loaded in to a particular book, it immediately creates a reference to that data set. So multiple data sets, and as you know, multiple data sets and multiple books can exist in a single workspace, and the data reference pane that we have in here can be used to help you manage these links. Gives you a bit of a graphical display as to what is referenced to what. The link checkbox can be used to quickly link or delink just the display of the records in a particular from a particular data set. That's useful in terms of if you want to say you have multiple data sets that have the same structure but different data in each of them, and you're displaying them all in a single book, and you can turn off the display of specific data sets so it doesn't clutter the environment, and you can compare one data set with another one and that sort of thing. Also, record data can be in a book can be relinked to another data set quick and easy, and I'll show you that as well. Okay, to help show the data referencing, I'm going to open up another example case that I have here on file just to help me do that. All right, so in this example, it's very simple. You can see that we have 3 books loaded up and 3 data sets. So if I select each book, the data reference pane down in the left corner is going to be associated with whatever book that you're currently looking at. So I've just selected book 1. It shows me that it has a data reference to the data 1 data set. And that comes from a DW3 under case.out file that is stored somewhere on my computer. If I select book 2, you notice that the link tick mark in the data reference pane shows that the book 2 is connected to data set 2. And surprise, surprise, book 3 is connected to data set 3. So I'm going to stick with book 3, but say for some reason that I want to relink the data in book 3 to the data in book 2 or in data set 2. So the way I would do that is to right click on book 3 and go down to a menu function called relink curves, select that, and I'll get a display. So this one tells me that there's a from box and a to box. I want to convert the data or relink the data from data 3 to, say, data 2. So I will select that and then press OK. So when I do that, the data is immediately relinked to data 2. So if I go back to book 2, if I select book 2 now, the results are going to be exactly the same because the two books are referencing the same set of data. For display of data, if I want to turn off the display, like as I had mentioned before, you can just select the tick box in the data reference and it will turn off the display. If you want to turn it back on, just reselect it and it comes back on. You'll notice if you hold the mouse over the graph, you'll notice that there is a flyby window that will pop up. This will tell you here what the data sources for all the curves are in that particular graph. It also gives you other information like the X point and the value of the curve at where you're holding your mouse. All right. So I mentioned before, quick loading. Very large data files, it can take a long time to load in. So Enerplot provides an option to quick load the data set. And what it does when it does that is it only loads the structure of the data set, not the data. So it's not bringing the data into memory. It's leaving it in the file, but it's loading in the structure of what the data set is going to look like. So that means that it's really quick to load up the data set. The record data is loaded only when it's selected for display in the graph. That's what's really nice about this, is that if you have a monster-sized data file and there's only a couple of records that you want to look at, then you can load it in with the quick loading feature, and then just plot those two records, and those are the only two records that will actually be loaded into memory. The data sets, once they're loaded, once they've been quick loaded, say you loaded that large data set in, and you've only loaded the data for 2 records into memory, you can then take that file and save it so that it creates a new file for you with only the records that you're looking at in it. And that's also a very quick and efficient feature as well. So I'm going to switch back to Enerplot again here, and I'll show you a quick demo of the lazy loading. So quick or lazy loading is on, it's off by default. So whenever you create a new workspace, the workspace options will be, by default, it will load all the data in when you load a data set. So I'm just going to open up the workspace options here and have a look. And this is the workspace option here that controls quick loading. And it's set for yes. So it's saying that if I load in a data set right now, it's going to preload all of the data. So I just happen to have a very big data set file somewhere on my computer here. So I'm going to load that up and we'll see how long that takes. So this is a PSSE output file. As you can see, it's about 225 megabytes. I am going to load that up now and we'll count how long it takes. So I'm going to do that right now. It should take about 10 seconds or so as it's loading in. And there it is. Okay, so we've got 811 records in there. Quite a lot. So you saw that it took about 10 seconds to load that in. So what I'm going to do is I'm going to remove that file. So I've just right-clicked on it and selected remove. If I did that too quick for you, there you go. Sorry, there's a little bit of a lag when we're broadcasting here. So I'm going to go back into the workspace options and turn the preload all data off, which means we're turning quick load on. And I'm going to press OK to accept those changes. And now I'm going to go back and load that same file again, 225 megabyte PSSE file. And here we go. So it should be of a couple seconds, 1, 2, there we are, completely loaded. So what you'll have, what I'm showing here is just the structure of the data file. What I can do now is, if I want to say load one of these records in, you just have to select the record, wait a couple of seconds, and you'll notice that the icon beside it now shows a little bit darker, and it's also now showing what the curve actually looks like. So now only the data from that particular record is loaded into memory, and I can hold down the control key, hold down my left mouse, and drag that across and plot that in the environment. So now that I have that set up, you'll also notice that down in the reference pane down below here, because I've added a curve to, this is book 3, because I've added a curve to book 3, it's added a reference link now to that particular data set automatically. So now if I can click that on and off if I like. So if I had mentioned now that this is a data file that has 811 records in it, but we only have one record that is loaded in. All I need to do now is right-click on that data set while it's still in here and select the menu option Save. It should say Save with plotting records. Sorry, it's still beta software, and we'll clean that up before it's released. But this is the function that does it. If you select that, then now you can create a new file that will only have that particular record in it. So I'm going to save that file as data2. So it created that file for me. I'm going to go back and remove this larger one. And let's go back and load that new file. So that was I created in CSV format. So I'm going to load it up and come in. As you can see, it has only one record, and it's that one record that I had actually. And as you can see, because I have lazy loading still turned on, it didn't even load that record. So I just have to select it again and There, now it's loaded into memory. Okay, that's quick loading. All right, next I'll talk about data manipulation. So record data, once it's been loaded into Enerplot, can be modified in a handful of different ways. You can, once it's in a curve or as a curve in a graph, you can directly scale the y-axis, or you can offset either the x or the y-axis as well, straight from the graph. You can, if you have some measured data that's a little bit choppy, we have a little quick, convenient little smooth function, which is basically just a real pole smoothing function that can help you smooth the data out if necessary. And plus, you can also select a curve and you can shift it manually on the graph using the arrow keys, using Shift plus arrow. This may be convenient if you have recorded data that may be a little bit misaligned. You're trying to compare it to simulated data, and perhaps it's misaligned on the XY axis a little bit. You just kind of have to move it so you can compare it better. And as I'd mentioned before, using the data view pane, you can manually alter the data in the data set as well, dynamically from the table. Okay, I'll bring back Enerplot again, and I'll show you some of that. So I'm going to go back to the standard examples file that I had from before, and I don't want to save anything. There we are. So here we are back again, and okay, so let's, I'm just going to delete one of these curves here so we can see things a little bit better. Actually, no, I don't want to do that. I will, can I paste that back now? Yes, I can. Okay, good. Okay, so, all right, firstly, I was mentioning that you can scale and offset the curve points. So let's take a look at DC volts. I'm going to right click and select curve properties. And in here down at the bottom, it says translation and scaling. Here I can add my offsets in. So I'm going to offset that by, say, 0.2. So I enter that in there, just press OK, and it offsets it on the graph by 0.2. All right, I'll undo that change. I'll go back in, I'll scale it. I'm going to add a multiplier to it, so I'll say scale it by 0.5. And there we go, scaled by 0.5. Now I'm going to undo that as well. Let's get rid of the green curve. Now, say this is an actual simulated curve, but say it was some measured data, and I wanted to smooth it out a little bit. I just simply have to go to the quick smooth function here. I'm going to put in a time constant, say 0.02, and that'll smooth the curve out for me as well. If I want to, I can translate these curves manually as well by using the arrow keys I had mentioned. So what I'm going to do is I'm going to hold down the Shift key, and I'm going to just move it around with the arrow keys, so you can see that it's moving the plot around the graph. Of course, the graph bounds are changing as I'm going because they're set to automatic. Now, for the data itself, you simply just need to click on the graph, left click on it, and you'll see that it populates the view data down below here. So now, as soon as I click on the graph, I have the hide data tracker on. It's going to give me crosshairs. So if I'm looking at a certain data point here, I'll go up to this one. I'm looking at a certain data point here. It automatically selects it for me down at the bottom in the data view pane. So now say that this data point is maybe there's a glitch in the measurement or something like that, and I need to modify that. I'll just change it to say 1.0 exactly. And so what that'll do now is it modified that one data point. If I zoom into that area, you'll see that one data point has been modified to 1. So as I mentioned, this data view pane is dynamic. As I click in different graphs, it will change and show me exactly what I'm pointing to. Depending on how many curves are in the graph, it'll show all the columns for it. This is even true for the FFT. If I click on the FFT magnitude, or phase area, it'll show me both the magnitude and phase angles of every harmonic that is displayed there. You'll also notice when I held the mouse over the particular curve, it tells me what its min and max are, the XY offset, the multiplier, time constant if it's a smooth curve, and it also tells me, it gives me a graph of what the entire curve looks like if it's not all plotted on the single display, and of course what its data source is. All right, the record wizard is a nifty little function that that allows you to create new records based on existing ones. So it also includes an embedded math parser. So it also possesses a bunch of math functions that you can also use to help generate new records. So back to Enerplot again. All right, so to use the record wizard, you need to, and I'm just going to reopen this case here, just to clean it up. There we are. Okay, so let's take a look at these ones here. So these curves are coming from, they are 602 VA, VB, and VC to neutral, and they're coming from the config data set. So 602, find those in the list. And there they are right there. Okay. So what I'm going to do is I'm going to select all 3 of those records. And what I'm going to do is I'm going to add them together to get what the neutral current looks like, or the neutral voltage looks like. So I'm going to select those 3, right click, and select record wizard. So this brings up the record wizard for me. I'm going to give it a name. I'll call it John for lack of a better word. And you'll see that there's a window here that shows the selected records in there that I can use, and all the math functions available in the list on the side here. So to create the sum of these 3 waveforms, I'm just going to double click on each one, and you'll notice when I double click on that, it adds it to the formula editor box down here. This formula editor box will be used by the math parser, so any text inside that, the math parser is going to read in and do any calculations that it needs to do before a new record is created. So I want to add that to the next one, so I have to go to the add, double click to add the adder on there, add the next record, add again, and the next record. So now it's going to create me a record that is the sum of those 3. So I press generate down at the bottom. And if I go back to my data set, you'll notice that there's a new data group here that was created for me, which is the output of the record wizard. And inside of it contains a graph called John, or a record called John. I'm going to take that and I'm just going to move this back here so we can still see it. Take that and create a new graph from it. And there we are. So this record here represents the neutral current of this three-phase voltage here. So that's the record wizard. Obviously, you can do. We have a collection of math functions in here. You know, from log to cos to square root, multiply, divide, take the power to the power of, all that kind of stuff. All right. All right. So last but not least, automation with Python. Now, as I had said before, this is the feature in Enerplot that hasn't been fully completed yet. It is not yet available in the beta, but it will be hopefully soon. So it's a completely embedded environment. There's a script pane inside, and there's a section in the workspace that you can add scripts to as well. When you install Enerplot, once this is in there, it's installed with all the automation-related support files, like the Python libraries and that kind of stuff, is all installed with the software. Python script files, as I mentioned, can be added to the workspace for easy access at all times. So when you save your workspace, all the scripts will also be saved as well. And the Python scripts, I can't demo this now yet, but when it's completely finished, you'll be able to generate new script files based on your own actions. So you can record your own actions within the Enerplot environment. Okay, so I'm going to open up the Enerplot Alpha. There we are. Okay, so what this workspace has in it is I already have a Python script that, interestingly enough, is going to be calculating the zero sequence waveform of a three-phase curve. But it's also going to do some other stuff as well. So the first thing I do is I'm just going to double-click on this script file, and you'll see that it immediately comes up in the scripts pane. The scripts pane comes with a run button and a stop button, and down below in this white space here is the output of the script tool as it's running. So it's basically an output window that you can display messages and that sort of thing in. So without getting into too much detail, what this is going to do is it's going to connect to this instance of Enerplot, and it's going to make sure that the workspace is clear of books. It's going to create a book to work in. It's going to load a file, load the data file to work with, fetch the data from Enerplot into Python, and it's going to perform the curve calculation, and then create a curve in a graph for you in the display. So I'll just press run here. Now keep in mind that we've slowed this down a little bit. It'll actually run a lot faster, but we've slowed it down just for the purposes of this presentation. So I'm going to press the run button, and we'll see it operate here. So you can see the messages coming in from down below. It created a new book, loaded a new data file for me, created a new group called data, creates a graph, and then places the curve on the graph. So that's it. Now, this is a very, very simple example, but as you can imagine, this could really, really help with if you you won't even really need to know how to script, be an expert, because we'll be able to, record a lot of this stuff and create the script file for you. Although you still will need to understand Python scripting a little bit in order to tweak your files and that sort of thing. Okay, I see I've probably run over time here already. So anyway, what I'm going to do now is I'm going to open this up to questions. If those of you that are interested, if you want to stick around and ask us some questions, you can ask the questions via the chat pane or the question pane or whichever one it is, and we can just answer you through voice now. So I'm going to mute my microphone and head over to the expert panel room. Thank you for listening, everyone, and talk to you soon.